All right, welcome to Chapter 11, Section 2, called Angles and Parallel Lines. This is for Integrated Math 1. So a couple things you're going to see on your screen. Before we get started here, the first thing should be a due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. You always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells us how many questions are on this particular assignment. Grading policy is the best score, so whichever attempt is the best one is the one you keep. Partial credit is enabled. So if you answer one of 3 questions correctly, you get credit for the one question or however many you answered correctly. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. What that means is once I click start here, down in the bottom right corner, I will see a submit assignment button. I need to make sure that I click that button to finish the assignment. That's what it means by finishing. So what it means when it says you can't work on anything else is that Alex is going to lock you out of every other assignment while this attempt is open. So if you just close this screen with the X, whichever corner it's in, or if you just close your computer, it's still leaving the attempt open. It's not submitting the assignment. So it's going to lock all the other assignments and your resources until you come back and finish this. So that's one really big reason to click Submit Assignment down in the bottom right corner. The other really big reason to click this Submit Assignment button is that it affects the grade book. So until you click that button, your account's kind of frozen on that assignment. We don't get to see what you've been working on. So 2 really big reasons to click it. It also, the program saves your place. So if you've answered some of these questions, you've gotten a green check mark in here, it knows that and it's going to start back up where you left off. All right, over here we have explanation, example, and message center. So explanation tells you you're going to lose your current question attempt because it's going to give you the answer to this question. So it's not going to give you the answer and let you come type in the or give you the solution and then let you come type in the answer. Example will give you a very close example to what it is we're looking at. Might be a different orientation, but very similar. I'm going to go through and give a review on what this screen on the side is talking about and kind of what we need to know in order to complete this problem. But definitely read through the example. Once you're good, you can close it. You can open another example if you want to see some more. Or you can message your teacher directly from the screen. It attaches a picture so we know where to come help you. All right, so before we get started, I'm actually going to go back and review what this diagram is teaching us. Because I drew this in the last video. So I'm going to go back and play that so that you can see what all the relationships are here and what all these arrows mean. All right, like I was saying, we have what's called a transversal. So we're going to call this the transversal. And I started to do this on the last video and realized we weren't actually using transversals in the last video. They just had a diagram that kind of looked like we were. I wonder. I don't know if I can get it to do this. Let's see. Oh. Darn it. I wanted it to be diagonal. Ooh, that's pretty close. Okay, I was trying to use my parallel lines tool and it was kind of sort of working there. Okay, so we have 2 lines that are going through and it's not perfect on here, but we're going to, pretend like these are. So these are parallel lines. Now in this diagram, they're not parallel, but the naming still works the same. It's the relationship that we'll actually see in the next section that's going to change based on whether or not they're parallel. So it does say parallel lines and transversals. For whatever reason, they don't give us parallel lines here. I can definitely see if I continue these down, they would cross somewhere down here, probably pretty far down, but they still look like they're coming together to me. So if we have parallel lines and a transversal, then we have certain relationships that go with them. And corresponding alternate interior and alternate exterior are the ones we're going to focus on. So corresponding means that they're in the same relative position. Well, what does that mean? So if I'm thinking of the transversal and I go from the transversal to the parallel, so I'm on the left side of the transversal and I'm above this parallel line. I want to try to repeat that exact same direction that I just did, or the direction system, I guess, that I'm using on the other parallel line. So I want to be on the left side of the transversal and above the other parallel line. So that's what I mean by the same relative position, meaning on the parallel lines are kind of in the same position. You can also see, and I'm going to try to do this nice and neatly, if I lasso this guy like that, so I can actually take this guy and scoot it, boom, right down into this one. And if you notice, they fit perfectly, don't they? So that is a very crazy, cool visual of corresponding angles are congruent. So I can also do that, and I'm going to undo so it doesn't look all funky like that. So I'm going to lasso the other side here. If I were to go on the right side and above the transversal, so let's see, why isn't it doing it? Oh, it was doing it, I just couldn't see it. Ooh. Okay, so I've lassoed that guy. Now if I bring this one down, look at that, it matches right on top. And I know it's not quite perfect because I'm not moving it quite right, but they do fit right into each other. Now this is only true, the congruent part is only true if the lines are parallel. So the two blue lines are parallel. Now in our diagram over here, they're not parallel. We can still say that angle 2, if I were to cut this one away and I could scoot it over into angle 6, angle 2 and angle 6 are corresponding, but they might not be congruent. They probably aren't because these two lines do not look parallel to me. And we can do the same thing. I'm going to undo that guy. So I'm going to lasso this inside one like this. Choop. Now I have that guy, and I can scooch this one down into this other spot here. So I really like this visual because I'm kind of just stealing the angle. So you can see they fit right nicely into each other. So it's kind of like corresponding angles. I like to describe them in class as they kind of slide. You can slide one right down to the other or one right up into the other. So they kind of slide back and forth, or if you're going side to side. So I can take, 2 and go over 6, or 4 to 8, things like that. So I'm going to go ahead and type this in. I'll go 4 to 8 since that's the last one I said. This is not the only two options. I can do this in the bottom, 1 to 5 or 3 to 7. So there's a lot of different options for corresponding angles. All right, if we go to alternate interior angles. So alternate has to do with, it kind of describes two things. So alternate means different sides of the transversal. So alternate, one side or the other. And it can be left or right, or like this one, our transversal's going left to right, so it would be above or below. Kind of just depends on your diagram. But different sides of the transversal. It also means kind of opposite sides of the figure. We want to make sure that we're paying attention to that idea too. Interior, so interior has to do with, what do we want to make interior? And I'll airbrush this guy. Let's see, do I have? I'm going to make that a little bigger so it airbrushes a little nicer. So the interior here, so this is the interior, in between the parallel lines. The exterior, we'll go ahead and make that green. Oh, no, we already did green. I'll make it bright green. So the exterior is going to be this outside area here, like this. So when we're using those words, that's what they mean. Interior is in between the parallel lines. Exterior is outside the parallel lines. So it's just kind of a very cute little visual so we can see very quickly interior, exterior. So if I want alternate interior, I want to be in the yellow area, the in between the parallel lines. So I'm going to just pick an angle here. So I'll pick this guy. So it's on the left side of the transversal. So I need to go to the other side, the alternate side, but I don't want to just go right across. I want to go right across and then kind of opposite. I want to go as far away as I possibly can without leaving the inside here. So it's on the right side and it's on the opposite end of the figure. Kind of an idea. So these two would also be congruent, and I can also lasso this guy because I really like these visuals. I think they help quite a lot. So if I just scoot it over, that doesn't quite work. But if I scoot it over and I spin this guy, come on, spin. Boom. Oh, look at this. Look how nicely it's going to fit right there into that angle. Oh my goodness. So it definitely works out the same way as the corresponding angles. Alternate interior angles are also congruent. So if I take this other side, I can do the same thing here. And I keep moving from kind of the top of the diagram down, but I could have also moved this angle to over here that the whole toolbar is covering up a little bit. But I could have moved that angle too. All right, so it doesn't work quite right until I spin it around like this. Now it will work. Boom. So it works out very nicely there where it drops right into place. Now if I kind of unspin it so that it, fits right back here, the main thing is, so this is on the right side. If I just go to the left side of the line, even if I spun this around, it's not going to fit into that spot. The only way we would have a congruent angle on the right and the left side is if we had perpendicular lines, meaning that they were right angles. Then they would be the same, but otherwise they're not going to be the same. And the reason we learned this, in a couple sections ago, these are linear angles or linear pairs, so they have to add up to 180. So generally one is going to be bigger and one's going to be smaller, and they're going to add up to 180, but they're not going to be the same unless they're perpendicular, meaning they're both 90 degrees. That's the only way we can have that happening. All right, so now we know in between the two lines, which should be parallel, but we're just going to stay in between. So this time we're in between here, so anything in here. So if I pick 4, I need to go to the opposite side of the transversal and slide as far away as I can without leaving the inside. So it's going to be 4 and 5. 4 and 5. Okay. So now alternate exterior angles, and I guess I will go, let's see, what color have I not? I haven't used bright blue yet. So with this one, I have exterior and alternate. So I know I want to be in the green, and let's go ahead and pick from the bottom because I keep picking from the top and going down. So we can pick from the bottom. I'm just going to pick this angle here. So this is on the right side. I know I want to go to the left side. That's alternate. But alternate also means go as far away as I possibly can. And in this case, since it's exterior, I want to go all the way to the other side. So it's actually going to be this green one that we've already used. So this is on the right side. It's the opposite side, left, right, and opposite sides of the diagram. And they're both on the outside of the parallel lines. So they're in that green area there. And again, I could cut this guy away and bring it right down here. It would fit right on top. Or I could do it with these two here. They would also work. So if I go outside the parallel line, so I'm going to go outside here. So I'll go ahead and choose number 1. So number 1 is on the bottom of the transversal. Since this transversal is going left to right, it's going to be bottom or top. So I'm on the bottom, so I want to go to the top and slide as far away as I can. So that would be 8. So 1 and 8. All right, and again, not the only options here. I can definitely choose other options. All right, check. All righty. So that was section 1 for chapter 11. I will see you in section 2. All right, so now that we've reviewed that really quick, and we remember, there's a lot of relationships, especially when we have parallel lines and a transversal. So coming over here, we can see 2 parallel lines are cut by a transversal as shown below. Suppose the measure of angle 7 equals 144 degrees, and angle 2, the measure of angle 2, find the measure of angle 2 and the measure of angle 4. So if we come over here, and we have boop, boop, we're going to pretend like I just drew parallel lines and I didn't, kind of mess that up a little bit. Here's angle 7, which we know is 144. And they want us to find angle 2, which is this guy, and angle 4, which is this guy. So I can notice a couple of things, and we didn't review one of them on the last screen there when I went over this one. But we also have, whenever we have lines crossing like this, anytime we have an X pattern, we have 2 things happening. We can do vertical angles, which is just me going across the vertex like this. Vertical angles are always congruent, so I can go, top to bottom, or I can go right to left, like that. Those will always be congruent. We also have what's called a linear pair. So I can go like this. These 2 add up to 180, or, oops, darn it, dropping my pen here, go away. Or I can go like this. These 2 are on a line. These 2 are on a line, or these last 2 are on a line. So this happens whenever we have 2 lines crossing. We don't need parallel lines and transversals for that, just 2 lines that intersect. So the reason I reviewed that really quick is because I have 2 lines intersecting right here, so I know that 4 and 2 are vertical angles, which means 4 and 2 are congruent. So if I can find one, I can find the other. So we need to think about how can we apply these rules to get angle 7 over here to angle 4 and 2. So there's a couple of different options, actually. Totally depends on what we see here. So I can take angle 7, and I can look at corresponding angles, because I can scooch it down over here. They're both in the same relative position. So this one here would be 144. And that's corresponding angles. Which I did in green on that one. Sorry, I was trying to remember since it was the last video there. Or I could use alternate exterior angles because 7 is on the outside here. I could go to the other side of the transversal and slide all the way down. So this guy would also be 144, which I can see vertical angles here. That makes sense that they're both 144. So either one of these would bring me over to the area where 4 and 2 are. So that's kind of the main idea here is once you look at what am I given, how do I take what I'm given and get it over to the same area as what I'm trying to find. And you're going to use, one of these properties that we just went over again. So either one would work, corresponding angles or alternate interior angles, and we want to make sure we're kind of making those mental notes. How did I get from one place to the other? Because when we're doing proofs, we want to be able to say, well, why? I know this one's 144 degrees, but why do I know that? I know that because corresponding angles are congruent. Or why is this one 144 degrees? I could say because alternate exterior angles are congruent. Or vertical angles are congruent. However, I'm justifying that. All right, so if I know that this one's 144 degrees, then I can use linear angles here. And I can say 180 minus 144, and that'll tell me what's left over for 2, or I could have gone this way and gone to 4. Either one, it would have been the same calculation. So if I subtract here, I get 6 and 3, so I get 36. And remember, they're vertical angles, so they're both going to be 36 degrees. All right. Let's go ahead and go to the next one. Guess I'll erase a little bit here. It's going to erase a little bit of my green, but that's all right. Okay, so this one says, in the figure below, L is parallel to K. So if you notice, they're not using the word parallel anymore. They're using parallel symbols. So we definitely need to be able to recognize that. They're going to start to use symbols instead of the words. Find the values of X and Z. So I have 2 parallel lines and a transversal. I know that this guy is 4Z minus 1. This one's X and this one's 83. So again, I need to figure out, I know one angle for sure. I need to figure out how do I get from here over to this area. And so there's more than one way to do it. I could again use corresponding angles and I could scooch this guy over so that it's in this spot. So this one's 83 degrees. And then I could use linear angles here. I could use vertical angles. I could also use alternate interior angles like that. Sorry, alternate exterior, I said interior. This is on the outside, it's on the bottom, so I can go to the top, like that, opposite side, and then slide out as far as I can over here. So this is also 83 degrees total. It equals 83 degrees. So either way, I bring 83 over here. So now I can either start solving for X or Z. Really, it doesn't matter which one I solve for first. I have to solve for both. So with this one, I know 4Z minus 1 either by using corresponding angles and then vertical angles or by using alternate exterior angles. Either way, I'm going to bring this 83 degrees over here. 4Z minus 1 equals 83 degrees. So now I can solve for Z by going through my process here. So I'm going to do addition, subtraction first. 4Z equals 1 minus 1 cancels, and this is 84. Then I'm going to divide by 4 on both sides. 4 divided by 4 cancels, and I get Z equals, and let's see, we have 2. 8 divided by 4 is 2. 4 divided by 4 is 1. So Z is 21. So yay, we found Z. X, so I can use this 83 or this 83 from the bottom. It doesn't matter which one I brought it over to. Remember, they are linear pair like this. So either I can look at this 83 and come over, or this 83 and come over this way. They have to add up to 180 degrees. I don't have to worry about this piece because I know the whole angle equals 83 degrees. So I can simply go 180 minus the 83 degrees. That'll tell me what's left over for my x. So I'm going to go 7, 10. So I get 7 there. And then 17 minus 8 is 9. So I get 97 for x. All right. Check. And let's go ahead and do this in the last one here. So now we have 2 pairs of parallel lines on this one. So they're just making it look a little bit more complicated. So now the transversal may kind of change position or change lines depending on which ones we're looking at. Because we have H and K, they forgot to label these. We have H and L. So they forgot to put labels on these guys, but this is H, this is L. They're parallel, and we also have J and K, and they're also parallel. So we have, you know, a little bit more going on. So we have these 2 pink ones that are parallel, and then we have these 2 blue ones that are parallel. If I'm looking at the 2 blue ones, either one of the pink ones is a transversal. If I'm looking at the 2 pink ones, either one of the blue ones is a transversal. Just depends on which lines I'm looking at there. So it does become a little bit more complex when we have all of these extra pieces in here. So let's see, I'll write this in green. So we have 3z minus 17, 64, and then y. So we need to figure out, because we need both z and y. So all I know for sure is the 64 degrees. So I need to start figuring out how am I going to move this 64 over to this area. So I can take the 64 and I can move it like this. So that's corresponding angles if I move it here. Or this is on the outside if I'm looking at the blue parallel lines and my pink transversal here. This is an exterior angle. So I'm going to move to the other side of the transversal and slide all the way down, and I can bring 64 over here. Either way, I can bring 64 down here to the y. So now I can very easily solve for this. These are linear pairs, so I'm going to go 180 minus 64. And let's see, that's going to get me 6 and 1 and 1. So that's 116 for y. Whoops, didn't mean to put that 2 in there. 116. All right, and let's see, what color have I not done? I haven't done red yet on this one. Okay, so now we need to figure out how do I get it from over here to over here so that I can solve for z. So now we're looking at the pink lines as parallel. And I have this 64 here, so I can slide it on over. These are corresponding angles, these 2 right here. They're in the same relative position on the parallel lines. They're both to the right of the parallel line and above the transversal, which is now this blue line here. So you just have to kind of ignore some of the pieces as you move around, but really any one of the lines can be a transversal, and then the other 2 that it's crossing, those will be your parallel lines. So it does move around a little bit more on this one. So 3z minus 17 equals 64 because they're corresponding. I could also do alternate exterior angles and bring it out here. So this is 64, and then vertical angles to bring it back in. A couple of different ways to do this. There's always more than one way. All right, so now we have plus 17, 3z, 17 minus 17 cancels, and I get 4, so that's 11, 6, 7, 8, I get 81, and then I'm going to divide by 3 on both sides. So z equals, and I believe goes in twice with 2 left over, and it goes in 7 times there. So I'm just kind of putting my leftover there so that I could easily do the division. All right, 27. Again, this is not the only way that we can go through and solve these problems. It's just kind of the ways that I saw them, but there are other properties that are not being introduced. There's actually one that's called same side interior angles or same side exterior angles. Those are also parts in here that can be related. But if you notice when I have 2 pairs of parallel lines, this guy and this guy are the same. So it almost kind of hops over here. So this one is 116, so would this outside one be 116. And then both of these interiors are going to be 116. If I brought this one in and this one in, they're both 64 and 64. So if you can see it's kind of mirroring all around. And it's just because of those double pair of parallel lines there. All right. So that was chapter 11, section 2. I will see you in section 3.